In this video, I'm going to introduce you to implicit differentiation. This helps us figure out what to do when the x's and y's are all mixed up. When you have a relation that's not a function, it doesn't pass the vertical line test. So let's look at an example. Here's a circle with radius 5. The equation for this circle is x squared plus y squared equals 25. I want to find the equation of the tangent line to the circle at the point 3, 4. So I need to find dy dx. Now, when I do this, I'm going to treat the inside as a separate thing so we can do the chain rule. So notice I will have 2x times the derivative of the quote-unquote inside, which is dx dx. Y squared, the derivative is 2y times the derivative of the inside with respect to x, so dy dx. And of course the derivative of 25 is 0. I want to emphasize this so that you see I kind of do this with the x's, but we don't write it down because it's just 1. So we don't need to write it down. So I have 2x plus 2y dy dx equals 0, and then I solve for dy dx to get negative x over y. I want the slope of the tangent at that point, so I will plug that point in and I get negative 3/4. So given the point and given the slope, I can use the point slope form. I need a little bit more room here. Let's see if I can, let's scooch that up. I have y minus the y coordinate of 4 equals negative 3/4 times x minus the x coordinate of 3. And when I simplify, I get negative 3/4 x plus 25 over 4. So next example. This cute little thing is called a Folium of Descartes. And the equation for that particular one is x cubed plus y cubed equals 4xy. I want to find the equation of the tangent at the point 2, 2. So again, we are going to do a power rule here, and we have to do a product rule over on the right, so let's just get to it. So x cubed becomes 3x squared, y cubed becomes 3y squared, dy dx. Over on the other side, I need to do a product rule, so I get 4y plus 4x dy dx. To solve for dy dx, we need to bring all the dy dx crap to the left and everything else to the right. Then we can suck out the dy dx and divide by the crap attached to the dy dx. So I get that the derivative is 4y minus 3x squared over 3y squared minus 4x. Now I want to find the equation of the tangent at 2, 2. Let's plug 2, 2 into the derivative. When I simplify, I get negative 1. And interesting enough, I'll bet if we had looked at that point, we would have been able to kind of tell ourselves or convince ourselves that the derivative is negative 1, but you probably shouldn't eyeball stuff like that if you're trying to be precise. So using the point slope form, y minus the y coordinate equals the slope times x minus the x coordinate. Simplify, I get y is equal to negative x plus 4. Now we don't always have a nice pretty graph of our equation. Sometimes we just get a nasty equation. Here we have x squared y is equal to xy squared is equal to 3y. We have power rules when we've got product rules. No quotient rules. I should have put a quotient rule in here. I didn't do that. Anyway, doing the product rule, and then just 3 dy dx on the right, I get 2xy plus x squared dy dx. That all came from the first expression. The second expression gives me y squared plus x times 2y dy dx. And on the right, I have 3 times dy dx. I want the dy dx stuff on the left and everything else on the right. So let's do that. Now we have to suck out the dy dx and divide by the gooch attached to the dy dx. So let's try one last example. X squared times sine of xy equals 5y. So I have a product rule. I also have a chain rule in here. And when I suck it out, we're going to have a bit of a mess. But that's okay. We'll deal with it. X squared sine of xy. First thing we get is 2x times sine of xy. Then x squared cosine of xy. I need to take the derivative of the inside, derivative of xy, and pull it out. And unfortunately, I now have this dy dx stuck inside of parentheses, and I have to solve for it. So I need to set it free. To do that, I'm going to multiply through by this x squared cosine of xy, and I will get this mess. The first term stays the same. Second, I now have x squared times a y. I put the y here in front of the cosine so it doesn't get sucked into cosine. X squared times the x, I get an x cubed cosine of xy dy dx equals 5 dy dx. So now you know the drill. We put dy dx stuff on the left, everything else on the right. Suck out the dy dx and divide by the stuff attached to the dy dx. So the derivative of that monstrosity is given here. I won't bother reading it because I'm sure that's boring as hell for me to just read through that. So we'll do more examples in class, but that's the basic idea.